The WSR-88D radar network is one of the main tools of the National Weather Service in achieving its mission of the protection of life and property and the enhancement of the national economy. Here at the New York Weather Forecast Office, we are co-located with our NWS Doppler radar, KOKX. So first off, just how high is KOKX, the radar, at least the radar dish, and where we send out the signal? Let's check out from one of our electronic technicians.
Hi, my name is Michael Cox. I'm one of several electronic technicians at the Forecast Office OKX New York. We're about 100 feet above the ground at our radar at OKX.
So as we just heard from Mike, and as we can tell looking down at our office, we're a good ways up there, but that's where we need the radar so we can scan the weather, which is what we want to see, and not trees and buildings. There's a look at our upper air station. You can see it well below us, down on the ground. We're about 100 feet in the air again. So the radar will slowly spin around looking at the horizon, and we'll look at more of that in just a little bit. But it will do so and scan the different types of weather that we may see out there. For instance, a sea breeze and the cumulus clouds associated with it. But before we look in the radome and what works up there, we must see where the signal is first generated, down on the ground. Don't look down too fast. So let's check in with Mike, who's down in the RDA shelter, and we get to let you pass those caution signs today.
Here we have the high voltage section of our Doppler radar section, 10,000 volts, and a modulator which produces voltage to drive our tube.
This device is also known as a claystron, and it's down here that basically is the heart of the radar, controlling the beat of the radar and the signal that gets sent out from up top where we were before to scan the weather. And what's the peak power of our radar, you ask? 750 kilowatts. So now we're up inside the radome, that white golf ball you see there in the sky. Our signal again got generated down on the ground, lots of power, and it's heading up to the radar. And the first place it heads into in the radar is what we call the pedestal. Pedestal consists of motors and wires and all sorts of parts that help to prepare the signal to head out to the radar dish, where it then gets sent out to see the weather. This motor, for instance, controls the elevation that the radar dish is pointed at. So how high up we can look at some of the weather that's out there. For instance, if we want to look way up at the top of a thunderstorm. So our dish is pointed where we want it, our signal's ready to go. It travels down this one tube called a waveguide. It actually happens on the other side of the dish as well, thanks to dual polarization technology. Travels down this tube, goes around the other side of the dish. As you can see, there's the waveguide continuing along. Goes to a device that's known as a feed horn. You'll see it here, right at the point. And the feed horn works with the dish to organize that pulse of energy going out from the radar. So we'll see those go out. And the radar is listening for any returns from those pulses back to it to tell if there's any weather out there. Radar actually spends more time listening than it does talking. It's a very good listener. So based upon the information of any returned signal back to the radar from any weather, bugs, birds, whatever the signal might have bounced off of, the radar then takes that information and, along with computer systems on the ground, turns it into those radar images that we're used to seeing, whether they be on TV, your computer, your smartphone, or elsewhere. And it doesn't stop there. NWS meteorologists and engineers are constantly looking at ways of improving our radars, such as the recent upgrade of dual polarization technology. These constant upgrades ensure that the National Weather Service continues to achieve its mission of the protection of life and property.